Aerosol is a small particle suspended in the air. We can find aerosol anywhere in our daily life, but it is too small that we cannot see. Size ranging from 0.5 micrometer to 100 micrometer, and it can suspend in the atmosphere from few days to weeks. Aerosols injected into the atmosphere directly are called primary aerosol. For those formed from chemical reactions are called secondary aerosol. Mineral dust, sea spray, and volcanic ashes are the natural sources, or they can come from smoke from industrial activities and vehicles. Aerosol plays an important role in climate. Some aerosol particles can collect water vapor and help cloud forms. Some of them can reflect sunlight and cool the earth. However, some of them can cause air pollution and affect human health. They can cause a variety of health problems. For example, PM2.5 fine particulate matter, meaning aerosol size not greater than 2.5 micrometer. Those small particles, less than 10 micrometers in diameter, can get into our lungs and bloodstream. Exposure to such particles will lead to health risk, so monitoring air quality and knowing more about aerosol is important. Organic compounds are common in atmospheric aerosols. They play an important role in particulate matter and ambient air quality. Hydroxymethyl HMS, is an important organosulfur compound in organic aerosol. It is a secondary aerosol commonly found in polluted environment. HMS can account for 10% of global aerosol sulfur in continental surface air and over 25% in most of the urban polluted areas during winter time. Sulfur in its organic and inorganic forms have different physiochemical properties, like surface activity, water uptake, and cloud condensation nuclear activity. OH oxidation of sulfonates is a way to produce inorganic sulfur species. Experiments have studied the mechanisms and subsequent transformation kinetics of this aerosol. For gas-phase aerosol, this oxidation flow reactor is used for investigating the heterogeneous OH oxidation of that. Sodium salts of HMS was used to prepare stock solution. OH radicals can be generated by using the UV lamp inside by photolysis of ozone. Heterogeneous OH oxidation occurs inside the tunnel. After oxidation, we can get aerosol stream. Some of them are collected by Teflon filter for chemical analysis by ion chromatography. Some of them are sampled with scanning mobility particle sizer for aerosol size and mass measurement by quantifying the amount of chemicals before and after oxidation. Aqueous phase aerosol can be studied by using other setup. To avoid the loss of aerosol, the reactor is covered by lid. Circulating cooling water helps keep the reactor at a certain temperature we want. UV light is extracted by filter from xenolite source. Oxidation occurs in the reactor solution. The extracted solution will then send to a spectrometer to analyze the amount of HMS. A sample of the ionized water in the spectrometer is used for comparison. By analyzing the absorbance, we can figure out what's in the solution. Kinetic model is also developed to investigate the decay of HMS and products formed, and oxidative kinetics can be determined by the decay of HMS at different OH exposure. From the experiment, organic sulfur will become inorganic sulfur. This conversion occurs in both heterogeneous OH oxidation and aqueous phase reaction. 50% of initial concentration of HMS drops at the maximum OH exposure after oxidation. Formaldehyde will then form upon oxidation. They can subsequently undergo a series of aerosol phase chain reactions to produce various inorganic sulfur species. Formation of inorganic sulfur species makes aerosols more hygroscopic than original HMS. Also, the formation of sulfuric acid will lead to the drop in pH. Aerosol is small, but it is important to us. They play a role in different atmospheric processes and affect our life. By studying aerosol and its interactions with other aerosols, we can better understand and predict the impact brought by aerosol and hence improve our air quality.